Hello everyone. Next acidic comparison, this one. Phenol, orthofluorophenol, metafluorophenol, parafluorophenol. Topic is for 12th JE NEET. Let's check. Technique will be same. Anions stability I will compare. A very special atom we have in this case, fluorine. Because this is the atom which is most electronegative in our chemistry. The highest value of electronegativity this atom have. 4. Electronegativity value is 4 there on a Pauling scale. Let's start. Out of these anions, let's compare the factors. The very first factor, plus R of O. Here also it is present. When I am writing plus R of O as a student, you should check it properly. Draw every resonating structure which is generated by oxygen like this. Full movement, 5 or 6 structures will be generated, completed. Now in this plus R of O, there is no role of fluorine. Now next factor. And you know this is stabilizing factor, S. It is trying to stabilize the anion because negative charge of oxygen will finish from it. Here substituent is not there, so no other factor is possible here. Here we have substituent, fluorine. Now fluorine directly attached to benzene ring carrying lone pair means it is able to show plus R effect, and which is on ortho position. So plus R effect is possible here. Plus R of fluorine. Now plus R of fluorine will try to destabilize or stabilize. Destabilize. When it will give electrons for the resonance like this, these pi electrons will move to next carbon here. Due to extra electrons, these electrons present between oxygen and carbon will feel repulsion and they will start moving toward oxygen, due to which the negative charge of oxygen will increase. So if oxygen is negative charge is getting increased, means oxygen is further getting destabilized. So this factor will be destabilizing factor. Destabilizing factor. From meta position, if it will show plus R effect, those electrons will not come on this carbon. So there is no effect of plus R on this oxygen. So I will say from meta position, no plus R of fluorine. From para position, it can show plus R effect because when you will show resonance, these electrons will come on this carbon, which will try to increase the negative charge of oxygen. So from here, plus R effect is operating, and which is destabilizing factor. Next, third, here no other factor. Okay. Fluorine, as I say, most electronegative atom. So obviously it will attract electron from carbon. In turns, this carbon will start attracting electron from this carbon. In turns, this carbon will start attracting electrons from oxygen little bit, due to which the negative charge of oxygen will decrease. Means minus I effect of fluorine will try to stabilize the oxygen. So this is a stabilizing factor. Here also minus I of fluorine, stabilizing factor. Here also minus I of fluorine, a stabilizing factor. Now here minus I effect will be strongest. Here it will become weak, and here it will be weakest. Now this factor is not able to decide the stability of anion. We need these factors. Here we don't have any factor, so leave it. Okay. Orthofluoro case. Plus R is saying I will destabilize the anion. Minus I is saying I will stabilize the anion. Which factor will dominate? In chlorine, bromine, iodine, the plus R factor was not dominating due to orbital bigger size. Chlorine, bromine, iodine lone pair orbitals have a bigger size, so they can't overlap with the pi orbitals properly. So plus R effect is not perfect there. Everything was told to you in that video. But here the size of fluorine and carbon is almost same, because if you will check carbon, its outermost energy level will be 2, and fluorine outermost energy level will also be 2. So they can show plus R very well. But because, as I say, fluorine is most electronegative atom. So obviously that electronegativity will make minus I effect dominates over plus R effect. No doubt plus R effect is operating here very well, because the orbital size are like this orbital and the carbon orbital. They are almost same. So they can show this plus R effect very easily. No problem. But note down one point. Fluorine is the most electronegative atom, the highest electronegativity. Highest electronegativity means very high power to attract electrons, like this, means minus I effect. So due to very high electronegativity of fluorine, still minus I effect is dominating here. Note down. Again, minus I effect is dominating here in ortho case. In chlorine, bromine, iodine, minus I effect was dominating because plus R effect was not proper due to bigger orbital size of chlorine, bromine and iodine, which can't overlap with small atomic size orbital of carbon. But here carbon and fluorine have same atomic orbital size, so they can overlap well. Plus R effect will be very strong here. But the problem is electronegativity is very high. That's why minus I effect is dominating here. Come here now. Here we no need to compare, very easy. Plus R effect is not there, so minus I effect is there. Come here. Now in this case, as minus I effect is getting weaker because fluorine is now far away from the oxygen. So in this para case, almost plus R effect and minus I effect will equalize each other. They will equal to each other. Or you can say they are cancelling each other. Yes. In para-fluorophenol case, plus R of fluorine and minus I of fluorine, they are almost balancing each other. One is saying destabilize, one is saying stabilize, and both are of equal power. So they are cancelling each other. So only in this case, only one factor will left here, that is this. Plus R of O. That's it. These are the points here. Now we will conclude it and we will find which is most stable anion. Let's check. Watch here now. Orthofluorophenol is getting stability by strongest minus I effect. It is dominating. As I say, it is dominating. Plus R was saying destabilize it, but plus R is very weak as compared to minus I here. Minus I is dominating. Minus I is saying stabilize. Means this anion is very well stabilized. By how many factors? You can check 2 factors. Okay, come here. This anion is also stabilized by 2 factors, plus R of O and minus I of fluorine. But this minus I is weak as compared to this. So it will also be stable but less as compared to this one. Check. 2 factors are making it stable. 2 factors are also making it stable. But here minus I is strong and here minus I is weak. So that's why this anion is less stable as compared to this anion. Come here. Plus R of fluorine, minus I of fluorine, they are getting cancelled. They are almost balancing each other. Plus R was saying destabilize, minus I was saying stabilize. And the powers are almost same because minus I is very, very weak because of distance. So they are getting cancelled. So only one factor is left, plus R of O, which is also available here, plus R of O. It is getting stability only by one factor, no? This factor is also available here. Means this anion and this anion, they are almost equally stabilized. Yes, very, very important and very rare case it is. Please note down, fluorine case. This anion and this anion, they are almost equally stabilized. So I think we got the order. It's a first molecule, it's a second molecule, it's a third molecule, it's a fourth molecule. Please check all factors again. Here must be a great focus. Plus R is done by fluorine easily because orbital sizes are matching. Plus R is easy here. Not like in chlorine, bromine, iodine. Chlorine, bromine, iodine were suffering from bigger atomic orbitals. That's why during plus R effect, they can't overlap properly with carbon orbital. So plus R is very, very weak here. But fluorine and carbon atomic orbital sizes are almost same. So they can overlap well, means plus R is okay here. But the problem is fluorine is very, very electronegative. So that's why minus I effect is dominating here. This one. But as you will move toward para, minus I effect will become weaker because of distance. And plus R, which is already getting operated, will balance it. So cancel them. Here plus R is not there, only minus I is there. And then finally we have concluded that what is the stability order? Let's check. The stability order is this. If I write stability order, increasing stability order, so which will be least stable? I think these two. Equally stable and least stable. Because they are getting stability only by one factor, that is plus R of O. Please check. Only one factor is making them stable. So first is equal to 4. First is equal to 4. And they are less stable as compared to third, which was getting stability due to plus R of O and weak minus I of F. And second will be the most stable anion here because it is getting stability due to plus R of O and strong minus I of F. This one. This is the stability order. That's it. So acidic order will be many acidic comparisons we have done. So I hope you now know that acidic order will be similar to stability order of the anions. So first and fourth means parafluorophenol and normal phenol will have almost same acidity. Meta will be more than that and orthofluorophenol will be most acidic among them. That's it. This is the order we have for phenol, orthophenol, metaphenol and paraphenol. Please check reasons carefully because this case is quite complex, not so easy. Thank you very much for watching the video.